How might our comprehension of science and the cosmos shift if the principle of mass-energy equivalence were incorrect, and the energy discharge associated with mass defects resulted from an explosion of the lost mass? In other words, what if nuclear energy is actually released due to a transition in the state of matter, and space is permeated with an extremely diffuse form of matter? Your question is essentially about a speculative scenario where our understanding of the universe is fundamentally different from what we currently hold to be true. The principle of mass-energy equivalence, encapsulated by Einstein's famous equation E=mc², is a cornerstone of modern physics, specifically in the field of relativity. If this principle were not correct, many of our current theories and models would need to be drastically revised or discarded. Here are some potential implications. Change in nuclear physics. The principle of mass-energy equivalence is crucial to our understanding of nuclear reactions, both in stars and in human-made nuclear reactors or weapons. If energy is actually released due to a transition in the state of matter, rather than by converting mass into energy, our understanding of nuclear physics would need to be fundamentally reworked. The mechanics of nuclear fission, fusion, and decay would need to be re-evaluated. Astrophysics and stellar evolution. Stars, including our own sun, generate their energy through nuclear fusion reactions, where lighter elements are combined to form heavier ones, releasing energy in the process due to the mass defect. If this principle is incorrect, our understanding of how stars evolve and eventually end their lives, in supernovae or as white dwarfs or neutron stars, for instance, would need to be radically altered. Cosmology. Our understanding of the Big Bang, black holes, and the expansion of the universe is grounded in the equivalence of mass and energy. This shift could drastically change our models of cosmology and our understanding of the universe's past, present, and future. Quantum mechanics and quantum field theory. The principle of mass-energy equivalence is a crucial part of quantum mechanics and quantum field theory, which are the basis for our understanding of the fundamental particles and forces in the universe. If the principle were incorrect, these theories would need to be drastically revised. Matter permeating space. If space is permeated with an extremely diffuse form of matter, this could lead to a new understanding of dark matter and dark energy, mysterious components of the universe that scientists are still trying to understand. It could also lead to a re-evaluation of the vacuum state, which in quantum field theory is not truly empty but is filled with virtual particles and quantum fluctuations. New physics. Perhaps most excitingly, if E=mc² were incorrect, this would open the door for new physics. This could potentially lead to new theories and models that could explain phenomena that our current understanding of physics cannot, such as the nature of dark matter and dark energy, the reconciliation of quantum mechanics and general relativity, or the nature of consciousness. It's important to note that this is highly speculative and not based on any current evidence. The principle of mass-energy equivalence has been thoroughly tested and is supported by a great deal of experimental data. However, thinking about scenarios like this can be a useful exercise in understanding the importance and far-reaching implications of our current scientific principles.